and welcome to this video on electromagnetic induction. We have a multimeter and we're going to attach these probes into it. We also have these neodymium magnets which will serve as the source of magnetism. We're going to attach the other ends of the probes to the exposed ends on this loop of copper wire. Right now, there are 4 loops in it. We're going to use the microamp setting on the multimeter because from experience, the currents produced by these kinds of experiments are extremely small. Let's put the wire loop close to the magnet. You can see there's a negative current produced until we stop moving the loop. When it is pulled back out, it produces current again, but this time with a positive sign. Negative, positive. You can see here that when the loop is moved slowly towards the magnet, that a small current is produced. And when it's moved a bit more quickly, a larger current is produced. Now, let's increase the number of loops from 4 to 7. 7 was chosen because it's the maximum number of loops allowed by the length of the wire. As can be seen here, increasing the number of loops also increases the amount of current produced by the loop. Furthermore, increasing the speed also increases the amount of current. Here, on this slow-mo, we can see that the maximum current produced was 61 microamperes. In summary, the rate of change in the magnetic flux density and the number of loops in the coil of wire are going to determine how much current is produced within the loop.